All right, let's take a look again at direct and inverse variation. Direct variation, as you might recall from way back when, has the general equation y equals kx, and that's our direct variation, where k is our constant of variation. We'll talk about how to recognize these on the table in the first couple of table problems on our worksheet. Let's take a look at the overview of inverse variation. Remember that inverse variation is where we had our constant product, xy equals k. K is still our constant of variation, but if I want my general equation, I need to have it in the form of y equals. So I'm going to divide both sides by x, and I get y equals k divided by x. And again, k is still our constant of variation. Let's take a look at some problems. We're asked to determine the relationship between the values in this table to decide if we have direct variation, inverse variation, or neither. So let's take a look at these numbers. As our x's get larger, our y's are also getting larger. So we can't have inverse variation because in the case of a constant product where one's getting larger, the other one must be smaller. Now let's see if we have a linear relationship, which is the first part of whether we have a direct relationship. So I've cleaned up my table so I can look at my first differences. Here I have a difference of 1. Here I have a difference of 3. Here are my differences 1. And here are my differences 5. On this side I have a difference of 4, a difference of 12, a difference of 4, and a difference of 20. And if I look at the ratio of first differences, it's always going to be 4 over 1. So I have 4 over 1, 12 over 3, which reduces to 4 over 1, 4 over 1, and 20 over 5, which again reduces to 4 over 1. So I have a first difference, or a slope, if I were to graph this as a linear relationship, which it is, because my first difference is constant of 4. So now I just need to make sure that I can write it in the form of y equals kx. And that means the y-intercept must be 0 because, remember, I could also write a linear relationship as y equals mx plus b, but if I have direct variation, then there isn't going to be a y-intercept. In fact, I can look at these as constant multiples. If I do 2 times 4, I get 8. If I do 3 times 4, I get 12. So I can just look at these as constant multiples. Y is just 4 times whatever x is every time. So I do indeed have y equals 4x. So that means that we do indeed have direct variation here because I can write the equation in the form y equals 4x, and because I can derive y just by multiplying x by something, which is also what this equation is telling us. We're going to have a straight line that goes through the origin if I graph this. Let's take a look at one more problem for this video and break to another video for questions 5 and 6. As my x's here get bigger, my y's here are getting smaller. So we don't have direct variation. We could, however, have inverse variation, so let's investigate what our product is. Remember that we have a constant product for inverse variation. So if I look at x times y over here, 2 times 6 is 12, 3 times 4 is 12, 6 times 2 is 12, 12 times 1 is 12, and 24 times a half is 12. So we have a constant product. And in fact, our constant product xy is 12. So I have the equation xy equals 12, or y equals 12 divided by x. There's my k, or my constant of variation. So we do indeed have inverse variation here, which we can identify by the constant product between our x's and y's, and that product is our k, or constant of variation, for this equation.